We're going to look at one last example. The summation in running from 0 to infinity of 2 to the n x plus 2 to the n over n factorial. Again, what do? I do the ratio test. The limit as n tends to infinity of a sub n plus 1 over a sub n. This is a sub n plus 1. Divided by a sub n means I just flip this. I get this. Notice 2 to the n plus 1 and 2 to the n just gives me a 2 upstairs. X plus 2 to the n plus 1 over x plus 2 to the n just gives me an absolute value of x plus 2 upstairs. And n plus 1 factorial downstairs, n factorial upstairs just gives me a 1 over n plus 1. So this is what it simplifies to. Now I take the limit as n tends to infinity of this. Remember, this is a constant, this is a constant. N tends to infinity. I don't care what x is. As n tends to infinity, this is 0. And 0 is always less than 1. So what do I conclude? That this series always converges. In other words, it converges for any value of x. All right, so what is my interval of convergence? All real numbers, which I could say is what? The interval from minus infinity to infinity, or equivalently, the set of all real numbers. What's my radius of convergence? Half the length of the interval, but this interval is of infinite length, so its radius of convergence is infinity. And that is the last example for intervals of convergence and radius of convergence. Bye.